So we talked about, so Greg gave a good overview of the platform itself. So we don't look at it as a box or a single solution. We look at it as a platform because there are multiple components here, including the software, the virtual appliances, the physical appliances, and the orchestration layer. So we'll refer to the rest of the presentation as a platform-based solution here. So why did we get into the public cloud, right? So we started this exercise about 3 years back when we started off in the private cloud. So we started off with VMware first for the private cloud for ESX. Then we started with NSX. Then we took it to the OpenStack layer. So there was a lot of interest in the private cloud visibility. Got that. Now the customers are migrating to the public cloud. So how do you get the same level of visibility in the public cloud as well? So that's how why we started on this journey for the solution to the public cloud. So this is typically what's going on in your environment or in the organization. The volume of the traffic, the speed of the traffic, your compute instances are growing at a rapid pace. Amazon provides new instance types every year, right? So their biggest announcements are around instance types and traffic. So that speed is going up. As those instances grow, the threats also are equally increasing. The hackers aren't sitting quiet, right? So with all that going on, where do you get the traffic and how do you inspect it? So we'll focus on the public cloud today. We already talked about the on-prem and the private cloud, but today we'll narrow down the public cloud and see how this solution can help the customers. So I usually start off with this picture. Now, this is not a Gigamon picture. This is an Amazon picture where they obviously provide the great foundational services for onboarding customers with the compute, storage, and networking. But it is the customer's responsibility to go secure the data, right? And people always wonder, is Amazon secure? Yes, they are. But is the customer using it securely? And that's what we want to act as the check and balance to make sure that is actually coming out through our solution. So if you look at that, Greg showed the slide about the accessing the CPU information, the memory information of the compute instances. Amazon does a great job. Conversation information, they have flow logs. Got it. But how do you get the live traffic part of it? That's what we are trying to address with the solution. There's no way. Right now, you cannot get those packets that you want to get in the cloud. And that's why we're trying to augment the Amazon components with our solution to get a full pervasive visibility into the cloud. Now, if you don't have this, we already talked about some of the challenges. How does a network IDS work? Right? Host endpoint protection is good. I mean, you can get some part of it, but how do you get it pervasively across what's going on in the cloud? What about advanced threat detection, DLP, SIM? So typically, these are all the tools that any SecOps team is going to invest in their on-premises to inspect the traffic. How does that get? How do you use those for the cloud? Right? That's what we are trying to address as well. You've already invested in those tools. You already have a mandate to go do that. Without the visibility, how do you bridge the gap? The other use case is also hotspots. Specifically to your question, on Tuesday afternoon, something is going on with my application. My web tier is slowing down, or my app tier is slowing down. What's going on, right? How do you look at the compliance? How do you look at the potential hotspots in that environment as well? And then finally, the last one is lift and shift. The lift and shift in this case is, as we track our customer journey through this process, they are taking an existing application in the on-premises, then moving it to the cloud. Right? Not re-architecting yet, but they're taking the application, moving it to the cloud, leaving the tools in the on-premises. So how do you bridge the gap between what's in the cloud versus how your security posture is in the on-premises? So that's a challenge as well. So without the limited visibility, you have all these hotspots or blind spots that we need to go address. So with that said, this is a good reference architecture. You always want to come back and say, how does it apply to an Amazon world? So this is a reference architecture and a classical 3-tier application, the simplest of deployments, right? So in this case, let's assume you have a 3-tier application. The way we call out is the north, south, and the east-west hotspots. North, south being anything ingressing and egressing into the web front end, and east-west behind that. Now, if this was an application that we had designed in the on-premises, you probably had all the things that we talked about, tapping and spanning and flow logs and all the good stuff to address that. How do you do that in the cloud, right? That's what we are trying to address in this world. A second use case, I think somebody asked about, do you need an agent, right? So a question to more ask is, how does the network look like? How are they traversing to the cloud? Do they use a transit VPC, for example, or do they use a single VPC, multiple VPCs? No two customers are the same, so they have different deployment architectures. So in this case, let's say they have a transit VPC. bridging across multiple other VPCs, probably because acquisition strategies, probably because they want to scale out across different regions, but they want to go through a single transit VPC. But you end up with the same challenge here, ingressing into the transit VPC, and then going out into that world as well. So how do you bridge this gap? So two problem statements, right? One is inside the application or transiting into the application. So if you take that, so now that we have known the use cases that customers are deploying, how do we go address the solution itself? So the challenge is, again, on the on-premises, you have a variety of ways to go do this. In the DMC, you can do a physical tap, you can do a span, or even for your out-of-band networks, you can do all these variety of ways to get access to the traffic, and including our own solution itself. But in the cloud, you have a variety of ways. I mean, if you ask Amazon or any cloud, and if you ask a question, do you have visibility, they'll say yes. But what does that usually mean? Amazon calls it CloudTrail. They call it X-Ray Vision. They have these products, but they are more focused on the API level visibility. Right? Yes, it is granted its visibility, but it's not the traffic visibility that we are talking about here. Another way is the VPC flow logs. Greg already covered in the middle tier of that picture, there's flow logs. You can do the conversations. But these are not content inspection, but these are just to say which EC2 instance is talking to another. How do you track those counters? A third way is these monitoring tools or the tool ecosystem starts deploying agents, right, for getting access to the traffic. Obviously, all three are available, right? But let's see what happens if you go the third route to get access to the live traffic. This is what will happen, right? Each tool vendor, and obviously we talked about multiple tools here, the IDS, for example, the network performance monitoring, the application performance monitoring, or any of the security tools, they're not playing friendly with each other, so they're all going to deploy their own agents in those EC2 instances. And then each of them is making a copy of the packet, copy of the traffic to the respective tool. You can already sense the problem here, right? Number one is the more you copy, you're going to eat into the compute instance cost or compute instance performance, right? And the other thing also is Amazon or any other cloud provider has some throttling on that EC2 instance throughput. So the more you copy, you got to bump up to the next level, and bump up to the next level. So now your application cost also goes up. And then finally, the other challenge also is your tools are never static, right? Your posture always evolves. Now, if you want to deploy a new tool into that architecture, now you've got to go back and change your application to inject that. It's not a scalable architecture either. The Gigamon solution is, let us be that one agent to access the traffic, right? Get the traffic out of that. Now, all the tools are still relevant, right? They're not going away. It's just that instead of them getting traffic directly from their agents, they're getting from our layer, our visibility layer inside the cloud. And then now they can all plug into the visibility layer and get access to the traffic. Right? So that's how the right side picture or the Gigamon solution allows you to scale out as you get more instances, for example, or if you want to plug in new tools into that tier, it's much more easier. Just plug into the Gigamon. The application doesn't even know what's going on. Right? So that way you keep your application pristine while your monitoring and security posture increases.
So is this a trade-off that people really hate installing any agents inside a VM, but Gigamon is saying, well, you only need to install one and hand off to all the other tools.
Right.
So that's going to, even though you don't want an agent, only having one's going to be better than having five.
You're absolutely right. I mean, people have called it agent fatigue in some cases, right? They have to monitor, they have to manage multiple agents, right? Multiple vendor agents, for example, and then each agent is running a different version stream, so your application is constantly churning to deploy their multiple agents. So why go through that if there's one agent that can get the traffic, as long as the tools can still get access to the traffic, right? I mean, that's where. So we're not playing a confrontational role of not eliminating the tool. The tools still get the traffic. It's just that Gigamon is feeding it from that agent, right? So the advantage again here, going back to your specific use case. So let's assume a web tier or maybe the web front end is slowing down because there's a lot of users on Tuesday afternoon, right? And then let's say we are acquiring the traffic in an agnostic fashion. And the visibility tier can say, for security tools, send it all the time. I don't want to make any judgment on when I get or when I don't get. But maybe on Tuesday, I might create a policy to say, for web tier alone, send it to this application performance tool for deeper inspection. But that way you can slice and dice or add the filtering into that to control how much traffic goes on. So any questions on this picture? Because this kind of sets the context for the rest of the presentation on the solution itself.
Can I just ask about, obviously this is all talking at a very IaaS layer with agents installed inside a VM, but enterprises are saying, oh, hang on, well, I'm now starting to use, let's use Amazon examples, DynamoDB. I've got IoT devices streaming things through Kinesis. How's Gigamon going to help with that when I've got a botnet attack happening over from my IoT devices? Nothing is actually necessarily going through an EC2 VM.
Right. So good question, Julian. So in fact, that's come up multiple times. So the way we are looking at it is wherever there's availability for traffic, we'll grab it, right? Whether it is in the transit VPC, the routers, and so on. But what we are also looking at, again, this is something that we need help from Amazon. We've been talking to Amazon as well to see, hey, how can we get access to traffic where we can't deploy ourselves, right? Can you actually give? So for example, let's take the Lambda use case. A Lambda function might be calling an RDS function directly without actually going through any EC2 instance at all, right? Totally. In that case, how do you get access to the traffic? So we are looking at maybe a load balancer. Maybe there's a service router there that actually does the traffic handshake. Maybe we deploy an agent there. So we'll show a demo where we are actually deploying on Nginx, for example, in a load balancer, and then use that as a gateway to acquire the traffic. Right? We are also talking to Amazon to see, hey, is there any other way you can give us a copy of the traffic as well if needed? The way we've designed this platform is, if you think about this picture, right? Okay. If you think about this picture, the right side of the architecture is kind of agnostic. We're designing in such a way that it's agnostic to where the acquisition comes from. Right now it's from an agent, right? But if Amazon says tomorrow I'll give you Kinesis access to the traffic, or if I give you a copy of the traffic that's going on somewhere else, and then stream it to you, we'll take it. Right? So that's how we have designed it to protect for the future.
So this is also a design decision that if an enterprise is deploying these very cloud-native things, but they feel they're going to need more security visibility, they're going to have to make choices. So they're either going to say, well, we're going to have to run EC2 instances to have the agent installed, or instead of using Amazon's built-in load balancer, we're going to have to use an Nginx one and write our own thing. So, so that's the trade-off.
You actually put it very succinctly, because in fact, when we were talking to one of the large customer who was thinking multi-cloud, for example, and they didn't want to tie in too much of their architecture to a specific cloud, and they ported over from different clouds, for example. They are designing it thinking of Nginx and thinking of non-Amazon-specific load balancers, for example. So they can take this application today, port it over to another cloud, still get the same performance. That's the reason why we're looking at Nginx, HA proxy, for example, as a sources to get access to the traffic. And we'll show how that also works.
Okay.
But your question is absolutely right. And also, I'll also be honest. So if you look at a customer journey from where they are at to a totally cloud-native with Lambda functions accessing Kinesis and DynamoDB, we are picking up every piece along the way from the traffic acquisition perspective. There are some use cases where we have to work through these load balancers and these acquisition technologies, but we are learning along the way as to how customers are deploying. And the other way they might do is, for tier 1 applications, they might use EC2 instances. For tier 2 and tier 3 quick functions, maybe they'll use Lambda services as well. So the exposure is minimal, going back to your point.
What kind of instances can you install the agent on? Windows, Linux,
so right now,
CSR, Palo Alto?
So good question. So right now we are focused on Linux. So our agent comes as an RPM and a Debian package. So you can install it on pretty much any flavor of Linux, if you will. For the Windows, it's on our roadmap, and we'll address that pretty soon. For Windows-specific use cases, because we can sit above in a load balancer layer, so if there are Windows workloads behind that load balancer, if it's an Nginx, for example, then you can obviously get that traffic. CSR we talked about. Now, Palo Altos and other tools are slightly different. In those instances, we're not deploying an agent. I'll show you a use case of how we extract traffic from there. CSR is a good example because since Cisco came with the networking construct, they do span off from the CSRs. So we can take a copy of the span traffic and then do the processing. Palo Alto is slightly different. They don't. We are looking at see if they can do spanning functions, which way we can extract the traffic out of there. More than likely, these commercial vendors wouldn't let any other agent sit in their instances, but how else can you extract the traffic? F5 is another good example. They have something called clone pool mirrors, where they can actually copy packets if needed. So we're looking at that as well as another option. Again, wherever there's traffic, we'll see if we can get access to the traffic. So a good example for Palo Alto, typically in this deployment model, kind of going off the slides here, but what they would do is they would deploy it in front of the web front end, right? And then usually they are front-ended with the security group or with the load balancer. So if that load balancer is a HA proxy and a Nginx load balancer, then you can see anything that's going into Palo Alto as well. Right? That way you've got that covered. So we announced this in November of last year. But what I do want to call out, a couple of important things here is we are an advanced technology partner. So we just didn't get into the cloud and then stay away, right? So we work with Amazon to get that partnership level because they put you through the grinder on, are you secure? Are you architected for scale? And so on and so forth. So they'll make you go through some architectural guideline checks and so on, checks and balances and so on. So we got that. Our solution is available on the Gov Cloud. As you know, Amazon has multiple regions, the commercial versus the Gov Cloud region, and most of the federal civilian agencies are in the Gov Cloud. And as Greg mentioned, a lot of our portfolio of products are sold into the federal agencies as well. So, and they have big mandates to move to the public cloud. So how do you get access to that? So we also announced the Gov Cloud region availability as well. And then we're also right now in the marketplace from a BYOL perspective, the customers can actually instantiate the software, run the software from the cloud, but then come back to our channel or come back to Gigamon for the acquisition. But we are looking at also a paid version in Amazon as well. So just a quick couple of points. So we are an advanced technology partner available in the Gov Cloud and also available in the marketplace. So if you go to the AWS marketplace and search for Gigamon, you should see that. Okay? And then we have built some automation. Obviously, everything in the cloud is automated. So we built some automation frameworks also to make it easy for customers to consume our solution as well. And we'll cover that a little bit. So we took that application. So we saw the hotspots, right? Got it. We saw how a single agent can address the traffic, can acquire the traffic. Now let's look at how that architecture now gets visibility. Right, our centralized fabric manager, which is our orchestration plane, uses APIs to connect to EC2 APIs, gets the inventory of the VPCs, more than one if needed, gets the inventory of the EC2 instances, for example, the networking constructs, and so on and so forth, because we need to know what's in that network before we go acquire the traffic, right? Got that? We're also paying attention to AWS CloudWatch events. The reason being that if more instances are spun up, how do you elastically scale out visibility without any user intervention? Right? So that's, again, we listen to CloudWatch events to go get that. We deploy our tier of visibility. Now, the reason why we always show a stacked set of nodes is because it's not static, right? You're going to grow. Visibility is going to scale. Just like compute instances scale out by application scale, so should visibility, right? Again, you don't want it to be a user-driven operation in the middle of a night to go get copy of a traffic from an EC2 instance. How do you automatically scale out? So we have a patent-pending technology called automatic target selection, where based on the scaling of the compute or the application, we can also scale out the visibility tier along the way as well. Then acquire the traffic. Typically, what customers have been doing is they use their CI/CD pipeline, put our agents as part of the CI/CD pipeline, so any EC2 instance that gets spun up automatically has our agent built in, right? And then now we can configure the policies to acquire the traffic from those EC2 instances and feed to Gigamon. And we're all orchestrating this behind the scenes. You know, all the customer is doing, all the user is doing is pick this application, right? Send it to this tool. We do all the orchestration. We do the underlying intelligence without any user doesn't have to go through the manual procedure of pointing and clicking the directions.
So as far as the installation of the agent on the instances, that's up to the customer to do somehow, either manually or through CI/CD
Chef
pipeline.
recipes. We have some example scripts and so on and so forth.
Are there any thoughts about using Gigamon and tying it into EC2 Systems Manager to actually do a run command and pass it?
Good point. We are actually looking at that to see if we can do some automation through those functions as well. Even maybe look at Lambda functions in case if an EC2 instance comes up, can you push it down, right? Learning along the way. But most customers that we have spoken to seem to have, because they want to tightly control that procedure, they usually use Chef, for example, or Ansible, or Salt, for example. Right. And as long as we make these agents accessible to them, they will figure out how to inject it.
I'm just trying to figure out, you're monitoring like Amazon CloudWatch events to know about new instances,
right.
But unless there's an agent on there, what difference does it make?
Yes, you're right. You only the assumption is in an EC2 instance, when the application scales out, when the load balancer picks off a new machine, or new EC2 instance, the assumption is that EC2 instance golden image is baked with our agent in there. Right? So let's say, for example, a customer might say this architecture, they may not want to monitor the web tier, app tier, but they want to see everything going in and out of the web tier. So the web tier images might have the agents built in, but the app tier images may not have the agents built in. Right? So again, they can choose how they want to do this. But the point is that they would make the decision of the golden images being refreshed with the images already in there.
I'm missing the point. You've got CloudWatch events that will tell you when a new instance pops up. Right. But unless there's an agent on that instance,
we don't care.
You don't care about it anyway.
Right. But we still need to know
figure out what CloudWatch events are doing for you.
But we need to know if the new instances have come up for us to go check if there's actually an agent in there. So we redirect. But let's say, for example, let's take this example. This instance might have come up, right? We need to go set up the mirrors to make sure that that mirror image, that traffic is actually copied over. So the way we will know that instance has come up is through an EC2 instance. So we'll go say, OK, good, we got an EC2 instance. Does it have an agent? Yes, it has an agent. That agent fits the profile of our rules policy. Now let me make the copy of the packet.
OK, so if I logged into a Gigamon instance or something, I'd be able to see, I've got these instances and these 10 don't have agents on them.
We'll show exactly how that.
OK.
So can you add on to that and have some policy-based alerting going, this is your suite, you think you're protected and monitoring all this kind of stuff, but hang on, you've got two ones that are missing.
Good point. So right now our topology will show which ones, in fact, our topology looks into the EC2 instances and networks to say which ones have monitored, which ones don't have monitored. But we are looking at alerting as well as a proactive alerting to say 20% of your EC2 instances have visibility and 80% don't, so you have a risk posture there.
I mean, I suppose in one way you maybe only need visibility on one end.
Right, exactly.
So you couldn't, because if the traffic is going between 2 points, you sort of at least.
So here's a good example in this is a perfect example, right? For ubiquitous visibility, pervasive visibility, you want everything. Let's assume you want, every instance should have it, right? But customer might say, if I'm in the app tier, anything coming from the web tier, I know, right? I mean, I'm going to get it. But the challenge is, if the web tier rejects a request, the app tier has no idea that something has happened to the web tier. So they could start off in the app web tier first, and then not bother about the app tier. But then pretty soon they'll find out your use case, an application is slowing down on a Tuesday. It could be the app tier that is the problem, which you don't get exposure unless you have the agent to acquire the traffic.
Yeah, I mean, you've got to decide. Because this can do so much analytics of the data, you've got to decide what's going to do. For example, are you going to use Gigamon to trap SQL injection attacks, for example, or are you going to use something else? So.
Exactly. And going back to your point, I mean, we have the way one of the profiling questions that we ask the customers, what does your footprint look like, right? I mean, and they'll say, well, I have 1,000 EC2 instances. Right? And now we'll say, how much of that is mission critical? I mean, some could be dev tests, they may or may not choose to do it. And they could say, well, 50% of this is mission critical. Then we'll say, okay, is it a typical classical architecture, a web tier architecture? Where would you want to secure it? Right? So then we kind of peel the onion to ask them the question, but they have the ultimate flexibility, right? I mean, again, the licenses is tied to how many instances you're going to monitor, so they have the flexibility to deploy where they want.
So it's licensed by number of instances, not by amount of traffic, for example?
Not today that's by the number of instances, but we are looking at amount of traffic, for example, amount of intelligence, for example. So today on the physical side, if the corollary on the physical side is, obviously you can buy the physical boxes, right? You can feed the traffic into the boxes, but then layered on top of that is what kind of ports, how many ports, what kind of intelligence you provide. So those are all licensable modules that you can get. Right now in the cloud variant, we have by the instances, but we are looking at traffic-based licensing as well from a consumption model. So if you go to this architecture, okay, so we acquired the traffic, great, we got all of that. Now you can send the traffic to all the tools that need it, right? Even though it shows one line, it actually is replicating that same traffic to multiple tools simultaneously. Now I want to double click a little bit on the tunneling because it's important. You cannot put the raw packet on the wire again, right? You have to encapsulate it because that's not the source and destination anymore, it's a different source and destination. So we've always believed in standard protocols, so we use L2GRE and VXLAN as a protocols to encapsulate packets, encapsulate the payload around it. And all these tool vendors that I talk about, and I'll show a slide on who those tool vendors are, they've all made the change to actually do L2 GRE decapsulation or VXLAN decapsulation. So they throw away the header. Now they've got the pristine packet to go analyze. Right? So when they move their variant of the tool from the on-premise to the cloud variant, they have encapsulated around, they do the GRE decapsulation, but the analysis engine is still the same. They're still looking at the same packets. It's just how they ingest those packets is slightly different in the virtual version of the cloud variant. The more important part, well, we got the traffic. That's great, right? Now you've done your analysis. What do you do with it? There are two options to do it. One is you can present your analysis, or you can take remedial action. When I say remedial action, there are multiple ways to do it. One, maybe that KPI said that EC2 instance is bad, let me go quarantine. That's one approach. The other approach is I started with a coarse grain traffic. Now I want to fine grain it. I want to dial up the granularity of how much traffic I need. You can program it dynamically. Again, all the things that we do with our user interface is expose, publish as REST APIs. So you can program it dynamically to go change, maybe granular, fine-grained traffic. Maybe redirect, maybe send a copy to another tool, for example, right? A longer persistence tool, for example. So again, that gives you the flexibility of those, of dynamically changing a platform to adapt to the customer needs. So here are some of the tools. So we have about 100 plus ecosystem partners, obviously, but some of these tool vendors have actually made the change to a cloud variant. Now, these did not, maybe one or two of them existed before we came up with the solution, but now that there is access to traffic, they're also moving along much faster clip to move to the cloud variants as well. So we got some good partners here. In fact, it's interesting. It's these ecosystem partners who talk to the customers, and the customer says, what's the cloud strategy? How are you going to get access to my traffic in the cloud? That's when Gigamon and that tool vendor work together to help the customer get the security posture. So obviously broke it up into three areas: security and vulnerability management, a whole bunch of tools there, the network application performance. I do want to double click a little bit on the open source. As you know, cloud is, a lot of it is they make things along the way, right? So some of the tools that we commonly see, Bro, for example, Bro IDS is a pretty popular open source based tool. Suricata, Security Onion, NTOP, Wireshark, all the techno Greeks out there use these without buying the commercial tools, but they obviously want to use the same thing in the cloud as well. So how do you get access to that? Right, so we work with those. And then a little bit on the Nginx and the HA proxy from a load balancer perspective. If you want to acquire traffic out of those, we can also do that. Right, so a good set of ecosystem that we're working with. So a couple of use cases. I just want to call out some customers. Some are publicly referenceable, some are obviously chose to be anonymous. But this is a Chicago Mercantile Exchange, a big financial institution that had mandates to move a lot of their workloads into the cloud. And they had some Gigamon hardware, but they were an all-in the cloud. So if you break up the customer into an all-in versus an on-premises / hybrid world, this fell into the all-in approach. And they wanted to get visibility. So one of the tool vendors worked with us to get access to the traffic as well.
Can I ask a slightly different question here? So as you kind of go through explaining the way that your products work with cloud, it sounds like you've taken a lot of the what you've done on-prem and kind of tried to tweak it to make it work, trying to fit it into cloud, into public cloud for AWS. My concern is that how is that going to work then when you go to Azure, then when you go to Google, then when you go to others? Hold on.
Sure.
So my question is really, has there been any discussion of maybe stepping back and saying, hold on, let's not try and tweak this, but rather we need a whole new approach to the way that we think about solving this problem, because cloud is very different. Has there been any conversation internally about kind of going down that path as opposed to trying to refactor or tweak each product, but rather to step back and say, let's rethink the problem?
So to answer that, actually, that is how it is evolved. We haven't, I'll go back to this slide. If we all concede that traffic is important, let's take that approach that traffic is important for visibility. If we take that approach, there are multiple ways to acquire the traffic, right? Either use the cloud provider's way to access the traffic. There are not any out there. So you got to come up with a way to acquire the traffic. The way we have thought about this is completely different from our hardware-based solution, because in the hardware, what happens? You acquire, you get one box, your network grows, you get another box, you get another box. In this case, that's not the case, right? You're scaling out automatically based on a cloud scale as well. So we've completely rethought that. From an automation perspective, the entire focus on REST APIs, for example, how do you scale out your visibility tier, or how do you granularize the traffic itself, is completely different from how we do on the physical versus the cloud variant. The third approach is this. You talk about Azure versus AWS. Our integration into the cloud is at this layer, right? Because we obviously need to use those respective APIs to get access to their inventory. But this technology here is pretty agnostic, right? This agent could live on an Azure workload. Doesn't matter. This protocol are pretty open. Either it's L2GRE or VXLAN. Those are pretty open protocols. This is, right now, it's obviously an Amazon machine image. But for an Azure, it'll be an Azure instance because you have to run in their world. So an EC2 instance cannot run in an Azure world. Just like that, we got to make our images available in that cloud. This protocol is open. These tool vendors, obviously, they have to make a decision whether they can live in Azure versus Amazon. That's their choice, obviously. These APIs are open. So the only integration to that cloud provider is these APIs. And then we all obviously concede that those APIs are going to be different from each provider. But we have designed the solution to be pretty portable and pretty agnostic of the IaaS provider on which we are running. I don't know if I answered your question, but we have designed it such a way that when we do Azure, when we do Google, our integration points are these and not this layer. And then the more important thing is we'll talk about some of the methods that we have made available for customers to try it out. We have test drives where customers can quickly do a sandbox test environments, automation scripts with Terraform, for example, right? Automation scripts with CloudFormation, for example. All those are specifically designed from the ground up for the cloud, and none of it exists, obviously, in the on-premise world, right? So there's a big difference between what we have in the on-premises and how we have thought through this design to be agnostic from a cloud perspective. Okay, so tools, again, we talked about this. Talk about the customers. I'll quickly go through this. Here's an example of a customer who actually wants to bridge it because they are in a classical lift and shift world. They have an on-premise, the tooling architecture sits in the on-premises, their security ops team sits in the on-premises, but their workloads are moving to the cloud. So how do they bridge the gap between the on-premises world and the cloud worlds? They actually made the decision to go get Gigamon in the cloud and Gigamon in the on-premise, bridge the gap between the two. Again, we talked about the federal agency, the same case. They again want to bridge the gap between the two worlds. So we picked a partner here because RSA is one of our good ecosystem partners, specifically the previous use case. They had the same challenge. They were, their customers were asking them, hey, we invested in your tooling ecosystem or in your tool. How do we extend this SIM posture into the cloud traffic? Right? Where do we get that, right? So the tool vendors, instead of them developing an agent, them doing another way of acquiring traffic, they said, okay, Gigamon, you give us the traffic, just like what we do in the on-premises, and then we'll take the traffic in the cloud as well. So a quick picture here is, for example, RSA already takes logs from the applications. They got that. In the cloud variant, what they do is they get traffic from our vSeries to their decoder, and then they feed it to their NetWitness server. So this way, customers can, from a security ops team perspective, the single pane of glass that they have applies for both the on-premises and the cloud. I mean, they don't have to change their procedures, right? It's just how they acquired the traffic that is slightly changed in this world. But they still have the same user interfaces and so on as well.
So just a quick, RSA NetWitness, I mean, particularly what do they do? I know
they are security analytics.
Just okay.
So they have two options. They have two products: security analytics, or what they call also as a SIM, security incident and event management. So that's one thing that they do. They also have a product called a Whiptail, which is kind of a threat detection tool as well. And this customer, they had both of them deployed, right? But they obviously didn't want to, and they didn't want to have two agents getting traffic, copy of the packets, get it to Gigamon, and then they feed both their tools. So customers already invested heavily in that architecture in the on-premises, and they were moving that solution to the cloud as well. So they were the conundrum of how do I get traffic, and then Gigamon and RSA work together to make this happen. Right, and we're seeing, actually, I specifically picked out RSA. We work with a lot of other partners as well because there was a recent win with RSA. And we're seeing a repeat of that same scenario come up at multiple other customers as well. So we thought we'll just call, do a shout out for them.
I'm assuming customers just know going in, if they're doing this in the cloud, it's going to be expensive. Because my guess is they'll have multiple accounts or multiple regions or multiple VPCs. You probably got your Gigamon in like a shared services or a security VPC or something that's separated.
Yeah.
All the traffic's going to be sent through a transit VPC, which is going to have a cost, and to another VPC, which will have another cost. And then we're going to share that data back to Gigamon, which is going to have a cost.
So the way they look at this is multifold, right? One is, that's where some of these filtering and intelligence capabilities come in. So we are acquiring and applying intelligence closest to where the application is. So you're not just doing a raw dump of all the packets out there. So you can filter it down in your VPC. And then typically a security ops team is thinking, hey, I have my set of tools in the on-premises. I want to have my own VPC in the cloud, right, for all my security operations tools. So they might go and deploy that VPC primarily because it's the shared services, right? They're doing it across multiple applications and business units. Now, the cost of how the traffic is obviously Amazon dictates the cost of egress. But if you are in the same region, for example, there's no cost, right? If you're in the same region and the traffic is traversing from one VPC to another, if you're using VPC peering, the traffic is kind of, the cost is kind of offset there. But if you're obviously going across multiple regions, then you have to factor that in. But what is that against a posture that you don't have or visibility that you don't have? What is that? What does the trade-off look like? Right? You're blind completely versus the cost of actually getting the visibility and so on. And our goal has always been to, number one, acquire and then make sure that the tools can actually get access to the traffic in an optimal fashion. So the intelligence is in the cloud, so you narrow it down, you get that coarse grain, you get that granularity of traffic, rather than just a dumb copy of everything over into the out of the cloud itself. So that's what we have done. And then we'll talk about a couple of the use cases specifically around multiple VPCs and how we acquire the traffic as well. So also, I'll also point out that just like our traffic scales out, our applications scale out, the tool vendors also have multiple capacity planning exercises. Now, they start off with this instance size, and then depending on the amount of traffic, they might have to bump up the instance. Again, each customer is different, and they'll do their own profiling of the traffic itself to identify what is the right instance size to acquire and analyze that traffic as well. Just like what they would do on-premise. They have a 1 RU box, a 2 RU box, a 4 RU box based on the amount of traffic, and they have to go through that same exercise in the cloud as well. That hasn't changed in this world.